welcome to debate. Imagine sitting down for a game of chess, right? And you haven't even touched a piece yet, but your opponent has already countered your opening, defended against your mid-game strategy, and, well, set up a checkmate trap.
Right, and it's not because they possess some, mystical clairvoyance. It's because they haven't just studied the board. They've mapped the underlying architecture of your decision-making.
Exactly. They've analyzed the specific hesitation in your wrists before an aggressive push, and, like, the slight eye dart before a defensive retreat. They convert those microtells into a predictive statistical model.
So today we are examining the phenomenon of AI predictive behavior modeling. We've entirely moved past the era of algorithms simply cataloging our explicit actions. What we click, what we type into a search bar, or what we put in a shopping cart. Yeah, the basic tracking days are long gone.
Right. Modern systems operate on latent variable modeling. They use sub-second micro-interactions to generate highly accurate, multidimensional statistical portraits of our habits. They effectively predict our decisions before we consciously formulate them.
And the central question we really have to answer today is what this capability fundamentally represents for human agency. Because we are dealing with systems that reverse engineer our psychological impulses for, third-party optimization.
I approach this from the position that these predictive capabilities represent a profound leap in technological convenience. By aggregating massive data sets, these models seamlessly fulfill our needs by anticipating them.
Anticipating or engineering?
Anticipating. Acting as a highly efficient, probability-driven tool that removes friction from our daily lives.
And I will argue that this is an invasive, continuous surveillance mechanism. It builds behavioral maps so granular that it creates the illusion of spontaneous choice. But in reality, our actions are simply the predictable, engineered outcomes of our mapped vulnerabilities.
I mean, look, we need to strip away the science fiction dread surrounding this technology and look at the actual mathematics of what is happening. This isn't mind reading.
It gets pretty close.
But it's not. It is a sophisticated application of high-dimensional probability matrices. By aggregating thousands of seemingly disparate data points, your scroll velocity, the precise millimeter where your thumb hovers over video, the time of day you typically abandon a transaction, the AI identifies a behavioral vector.
Right, a vector that it then exploits.
Well, it then matches your specific vector against millions of similar user profiles. And the utility here is unprecedented. It connects supply and demand with near-zero latency, offering the exact product, content, or, financial tool you need, precisely when your historical data suggests you want it.
Okay, but you're framing this purely as an optimization of supply and demand, which completely obscures the cost of that alignment.
The cost?
Yes, the cost. This system requires absolute, constant surveillance of our most vulnerable cognitive states to function. When an AI builds a behavioral map, it doesn't just note your preferences. It calculates your cognitive load. It maps your emotional triggers.
I think trigger's a bit of a loaded word here.
But that's what they are. By tracking patterns that indicate when you are stressed, tired, or distracted, the technology exploits your psychology. It nudges you toward outcomes optimized not for your well-being, but for the platform's metrics. Maximizing time on site or maximizing margin.
Let's look at how that alignment actually manifests in the real world, though. Because calling it surveillance implies a malicious observer, rather than a passive statistical mirror.
Passive? I wouldn't call it passive.
It is passive in its intent. Prediction shapes our environment to eliminate waste and fatigue. The source material points to very practical applications. Streaming platforms that surface the specific narrative structures you are highly probable to watch.
Sure, the endless binge loop.
Or digital storefronts highlighting dynamic discounts you are statistically likely to accept. It operates on a very straightforward premise, right? Users who generate this specific behavioral cluster usually find value here.
Value for who, though?
For the user. Look, if you have a highly specific niche taste in cinema, forcing you to spend 45 minutes scrolling through irrelevant titles is simply a failure of design. Instantly mapping your past preferences to a high-probability match is friction removal at its absolute finest.
Yeah, but removing friction isn't inherently a virtue if the friction is the very thing that allows you to think critically.
That's a huge leap.
Is it? When an algorithm surfaces a show it predicts you will binge, it relies on a reinforcement learning feedback loop.
Your past behavior trains the AI, and the AI then alters your digital environment, so your next choice inevitably follows that exact same script.
It's just giving you what you want.
No, it has moved from being predictive to being prescriptive. It isn't just handing you a movie. It is constructing an architecture where the path of least cognitive resistance perfectly serves its own engagement metrics.
Consider the traditional neighborhood shopkeeper. We historically romanticize the highly attentive merchant, right?
Oh, I see where you're going with this.
The one who remembers a customer's tastes, notices what items they linger on, and anticipates their needs before they even articulate them. The shopkeeper says, "Hey, you always come in on Thursdays for the sourdough, so I kept a fresh loaf behind the counter for you."
Right.
We consider that the gold standard of personalized service. A predictive algorithm is simply the digital, mathematically scaled version of that exact dynamic, anticipating a need based on observed historical preference. Framing it as a prescriptive, sinister manipulation misrepresents the fundamental nature of the service.
I'm sorry, but I just don't buy that. Let me tell you why. The shopkeeper analogy fails on one massive fundamental variable:
Which is?
scale and capability. Your neighborhood baker doesn't follow you home.
Well, obviously not.
He doesn't monitor your biometric indicators to detect a spike in cortisol or analyze your sub-second hesitations to calculate your exact level of cognitive depletion.
That's just data granularity.
It's totally different. Furthermore, if we really want to use this shopkeeper analogy to describe AI, we have to imagine a shopkeeper who actively hides the bread you actually want in the back room, dynamically raises the price of milk because he noticed your eyes are bloodshot from a lack of sleep, and physically locks the store doors until you interact with a specific advertisement.
Okay, now you're exaggerating.
I'm really not. That isn't passive observation or good service. That is active environmental engineering.
You are assigning a malicious intentionality to a system that is purely reactive. The machine does not want to trap you. It is dynamically adjusting variables in a multi-armed bandit testing environment to find the highest probability of a successful transaction.
Exactly, a transaction.
Right, but if a user routinely purchases an item at the end of a discount window, the system adjusts the placement of tempting offers near that deadline. It is just calculating the optimal moment of conversion.
But the optimization of that conversion is entirely predicated on leveraging psychological vulnerabilities. The material explicitly highlights how predictive modeling targets well-documented psychological mechanisms: confirmation bias, habit loops, instant gratification reflexes, and emotional triggers linked to relief.
Which are all part of human behavior.
Yes, but if an algorithm calculates that your scroll velocity increases and your dwell time on low-effort content lengthens past 11 a.m., it hasn't just noticed a pattern. It has mathematically mapped your fatigue. It knows that your cognitive resistance is depleted because it has seen this exact vector play out in thousands of other users.
I see why you think that, but let me give you a different perspective. Recognizing a state of cognitive depletion is simply recognizing a data cluster. It is a necessary variable for the model to function accurately.
But look at what the model does with that variable. When it recognizes your fatigue, it does not prompt you to close the application and go to sleep.
Obviously not. It's not apparent.
Exactly. It instantly recalibrates the feed to serve you the exact type of frictionless, low-value content required to keep you engaged for another hour. It exploits the vulnerability. It times tempting financial offers right at the end of a stress-inducing countdown timer because it knows the emotional relief of saving money at the last second will bypass your critical thinking and trigger a purchase. You are no longer making a conscious choice. Your impulses are being triggered like a reflex.
You're looking at this through a highly pessimistic lens that ignores the macro-level utility. We're demanding that algorithms optimize for our convenience and then acting shocked when they use the necessary behavioral variables to achieve that.
We didn't demand to be psychologically mapped.
Yes, emotional and cognitive states precede actions, and AI maps those states using latent variables. But this profiling has critical applications that extend far beyond targeted ads or endless scrolling.
Like what?
Well, the text demonstrates that these exact same predictive mechanics are deployed in crucial sectors like healthcare, hiring, and insurance.
They are used to predict risk, performance, or adherence.
Oh, deploying these models in critical infrastructure doesn't legitimize the surveillance. It simply raises the stakes of the manipulation.
It allows for systemic risk management that was previously impossible. If a healthcare algorithm can analyze a patient's behavioral vectors, their response times, their physical mobility patterns tracked via smartwatch, their engagement with digital health portals, and predict that they are statistically highly likely to default on a life-saving medication routine.
But wait,
Let me finish. The system intervenes before the failure occurs. It alters the messaging to provide specific support. In finance, forecasting how likely someone is to default based on behavioral spending patterns allows institutions to dynamically adjust installments or restructure debt proactively. This keeps the individual within the financial system rather than failing out of it entirely. This is the stabilization of complex societal systems.
systemic risk management makes sense on a macro scale, I'll give you that. But you're completely ignoring the punitive nature of those interventions on the micro scale.
How is a proactive debt restructuring punitive?
Because in finance, predicting a default based on a behavioral model rarely results in a benevolent debt restructuring. More often, a multi-armed bandit algorithm detecting financial vulnerability will dynamically adjust interest rates upward in real time.
Well,
It penalizes the user based on a statistical assumption of their future failure, thereby causing the exact financial distress the model predicted. The algorithm essentially generates a self-fulfilling prophecy. And because the AI constantly anticipates and subtly restricts your options based on its own forecast, it creates a persistent, quiet unease. Your environment is essentially a tripwire designed to trigger specific outcomes.
okay, if we accept for a moment your premise that this digital environment acts as a tripwire, how is an individual supposed to operate? Whether one views this as a triumphant management of complex systems or, as you say, an invasive reverse engineering of our autonomy, the user still has to navigate the resulting landscape.
Right.
The text notes this widespread, quiet unease. So what is the mechanical response to a highly optimized environment?
The mechanical response is to actively reclaim unpredictability by degrading the model's confidence.
Degrading confidence?
Yes. The core strategy for regaining digital autonomy isn't simply logging off, it's disrupting the algorithm's statistical certainty. The more aware you are of how AI calculates our behavior, the more effectively you can inject variance into the dataset.
But how do you practically inject variance into a system designed to process millions of behavioral permutations a second? It expects variance. It builds confidence intervals around it.
You utilize intentional friction. In data science terms, you are effectively poisoning the dataset that profiles you.
Poisoning it.
Yeah. The material outlines specific, actionable methods for this. You skip the obvious, highly optimized recommendation, even if it perfectly aligns with your current desire. You deliberately abandon carts. You click on content completely orthogonal to your established tastes.
So just acting randomly.
Yes, acting unpredictably. You force a physical pause before reacting to an urgent red badge notification. By introducing this random noise, you flatten the probability curve. You widen the confidence intervals to the point where the system can no longer accurately predict your cognitive state. You stop acting on the instant gratification reflexes it has mapped, and you reclaim the very unpredictability that makes human decision-making autonomous.
The concept of intentional friction is fascinating, honestly. But framing it as dataset poisoning fundamentally misinterprets how adaptive these systems are. I actually view this as a testament to the system's incredible flexibility.
Flexibility?
Yes, by deliberately diversifying your digital inputs, pausing before clicking, or regularly scrubbing your interaction histories, you aren't breaking the machine. You are proving that you retain control over the feedback loop. The system is designed to continuously update its weights based on new data. If you change your inputs, you just shift the probability matrix.
But placing the burden entirely on the user to constantly generate mathematical noise just to outmaneuver a machine processing millions of data points a second, that is an absurd requirement for basic autonomy. You are asking human beings to act irrationally just to prove they aren't robots.
It is not about acting irrationally. It is about active, conscious participation.
The text points out that over time, engaging with these systems trains not just the algorithm, but the user's own habits.
Uh-huh.
This is where the true value lies. By engaging in these deliberate acts of intentional friction, users shift their decision-making from an unconscious reflex back to conscious reflection. The predictive model inadvertently acts as a mirror.
A mirror?
Yeah. If the algorithm surfaces low cognitive load videos because it has detected your fatigue and you recognize that algorithmic shift, you are suddenly prompted to reflect on your own exhaustion. You realize, oh, the system knows I'm tired, which means I am falling into a predictable pattern. The technology forces an awareness of our own behavioral tics.
I wouldn't call that a mirror for self-improvement. I call that a necessary defense mechanism against behavioral exploitation.
Defense mechanism seems strong.
It's accurate. The fact that we have to actively engineer friction into our own lives just to maintain a baseline of conscious thought proves exactly how invasive the technology has become. Look, the convenience we enjoy, the seamless streaming, the instant financial approvals, the perfectly timed discounts is undeniably real. But it is heavily subsidized by our cognitive autonomy.
I hear you.
When we consistently allow algorithms to dictate our path of least resistance, we slowly atrophy our biological ability to make spontaneous, unprofiled choices. The muscle of independent decision-making weakens the less we use it.
Well, let's summarize where this leaves us in light of the mechanics we've discussed. AI predictive models represent a monumental triumph of data aggregation and convenience. They function as incredibly sophisticated, high-dimensional probability matrices that seamlessly remove friction from our digital and physical lives.
Right.
From anticipating the exact content that will provide value, to managing severe systemic risks in healthcare and finance through latent variable modeling, the sheer utility is undeniable. However, to maximize this utility without surrendering agency, users cannot be passive consumers of a tailored environment. We must actively engage with the system, utilizing intentional friction, not as a rebellion, but as a tool to consciously train the algorithms and maintain awareness of our own behavior.
And my position remains that this unprecedented convenience comes at an unexceptionably steep cost. The system does not merely anticipate our needs. It actively leverages our psychological vulnerabilities, our cognitive depletion, our ingrained biases, our emotional stress, to engineer an environment optimized for third-party goals.
Which I still argue is just efficiency.
By reverse engineering our impulses through multi-armed bandit testing and biometric mapping, this technology fundamentally alters our relationship with our own decision-making process. Therefore, actively introducing mathematical noise and intentional friction isn't just a lifestyle preference. It is an absolute mechanical necessity for degrading algorithmic confidence and preserving our human autonomy.
Well, while our perspectives clearly diverge on the fundamental nature of this modeling, whether it acts as an optimal tool of convenience or an invasive mechanism of environmental engineering, we clearly converge on the critical importance of maintaining digital autonomy.
Absolutely. Understanding the specific data science, how the algorithm calculates our dwell times and maps our fatigue, is the only way to effectively reclaim that agency.
There is an intricate, undeniable complexity to our relationship with these systems. And there is much more to uncover regarding how behavioral vectors are mapped and utilized across vast digital ecosystems. We leave it to you, the listener, to observe your own interactions.
Definitely.
The next time you sit down at the board and the screen flawlessly anticipates your very first move, you have to ask yourself, who is actually playing the game?